A residual plot is a graph that shows the residuals on the vertical axis and the independent variable on the horizontal axis. So basically what we're doing is that we're taking our original graph and I'm replacing all the y values with the residuals. And what ends up happening is that essentially the graph, whatever our line is now going to become a horizontal line. So creating a residual plot is like tipping the scatterplot over so the regression line is horizontal. Now, if these points in the residual plot are randomly dispersed around the horizontal axis, so if your points look more or less like a horizontal band, then a linear model is appropriate for the data. Otherwise, a different model, and perhaps even nonlinear, is more appropriate. So in this case here, I draw the line. You can see that the points are generally above and below, kind of randomly above and below. This is something that you'd expect to see for a good residual plot. So this is what we expect to see if the line is going through the points pretty well. Now, here are 3 graphs. So the figure below shows 3 scatter plots with linear models. Can you identify any patterns remaining in the residuals? So for the one on the left, nothing really stands out. This is the ideal. In that if this looks like the points are generally randomly above and below a horizontal band. This is a good situation. This means that our line is going through the points pretty well. So a linear model is good. The one in the middle, on the other hand, if you look at the residual plot, there appears to be a bend in the data. This is telling me a linear model is not a good fit. So a different model would have been better. The one on the right, I see dots randomly above and below. So this is telling me a linear model is as good as anything. The scatterplot's pretty weak. Without the line there, I probably wouldn't have been able to tell if it was a positive or negative correlation. The line's going upwards, so positive, but the residual plot looks good, so this is saying that the line is about the best you can do. It's not great data, but it's the best you can do. So again, this first graph, this is the ideal situation for us. The scatterplot shows a strong negative correlation, and the residual plot looks like a horizontal band of random dots. So this line is a good fit for the data. For the middle one, there is a definite bend. So both the scatterplot and residual plot shows a noticeable bend. This is not a good fit for the data. There are better models that you can use. Last one, it has a positive correlation, but the strength is moderate or even moderate weak. You could even argue weak if you want. The residual plot looks like a horizontal band, so the line is basically about the best you can do, but the data is pretty limited. All right, so let's look at some of the equations we thought that were created to kind of explain the cricket data. So this first model, this is where the temp is negative 2,930 plus 100 chirps. And you see it looks more or less like a vertical line. You can see in this case, it does not fit the data at all. This is a very bad model. And what's happening in the residual plot, this looks like a line, but it's not horizontal any means. This is a bad fit. What we want to see is a horizontal band in the residual plot. That's not what's happening here. Here was 56 plus 0.375 times the number of chirps. Again, kind of a bad fit. It's really not going through the data very well. And you can see that the residual plot is not horizontal. So this is a bad fit as well. This one, looking a little bit better, is kind of going through the data, though not great. The equation 45.8 plus 0.738 times the number of chirps. The residual plot is definitely kind of tilted, so not horizontal at all. Then when I started this lesson with 37 plus the number of chirps, on the surface, it looks like the line goes through pretty well. The residual plots, definitely a little bit of tilt, not much. So anyway, it's improvement over the previous examples, but this is still not really the best fit. The best fit is this one here, where 40.0 plus 0.892 times the number of chirps. Maybe a little hard to tell from the graph, but I mean, it looks like it goes through as well as the previous one. But the residual plot, this line is horizontal. The points seem to be randomly above and below. This is a good fit.